Okay, so our textbook at the beginning of section 2 does address the difference between mass and weight. Mass is the amount of matter present, and it does not depend on the gravity or the force that's acting on that mass. So the big difference is that if something goes into space, it can be weightless, but it can't be massless. So weight does depend on the force of gravity of an object. Your weight can change if you are in outer space or on the moon or on Jupiter, but your mass would not change. Mass would be measured in grams, kilograms, so the metric system focuses more on mass. Weight is what is measured by the old English system of pounds, ounces. However, since the measurements that we are taking are all going to be referred to on Earth, so maybe in a physics class this might change, but in this chemistry class we're going to be talking about things always in Earth's gravity. And so a mass of 1 kilogram in Earth's gravity is acted on by that force that is 2.2046 pounds of force. And so we are going to use this relationship between kilograms and pounds, even though technically kilograms is mass and pounds is weight. We're going to be talking about them as if they're equivalent, but it's nice to remember the difference between them. Okay, no matter what amount of substance you have, or what planet you're on, we can classify the type of matter that we are talking about, either as pure or as a mixture. So that's a pretty basic distinction. Something's either all one thing or it's a mixture of different things. Then we have some subdivisions here. A pure substance can either be an element or a compound. An element has a symbol on the periodic table, so that's pretty straightforward. Oxygen is an element. In nature, it usually exists as a molecule with 2 oxygen atoms, but it's still pure oxygen. That still counts as an element. Other chemical formulas that have more than one element in a fixed ratio, like water, that would be a compound. So if a chemical formula can be written for something, then it is a compound. Except if that formula is all the same element, then we would still count it as an element. A mixture cannot be written as just a chemical formula because you can vary the ratio of compounds. We write H2O because water has 2 hydrogen atoms for every 1 oxygen atom. But if you had just a mixture in a tank of hydrogen gas and oxygen gas, you could change the ratio of those components. And so that would just be a mixture. If it's mixed uniformly, it's homogeneous. And if it's mixed, if its composition varies and it's not mixed uniformly, then it's heterogeneous. If you can tell the difference in composition even under the microscopic level, then it still would be heterogeneous. So for example, if you mixed sugar and water, the sugar would completely dissolve and you would not be able to tell where the different sugar particles were in your water. It would get clear. If you mix flour and water, or if you had milk, it might look pretty uniform. Hopefully it doesn't look chunky, otherwise you need some new milk. But and you can stir the flour and water until it looks pretty well mixed, but it's still cloudy, so it's not completely uniform. And if you left the flour and water, the flour would kind of sink to the bottom. So that would be a heterogeneous mixture, whereas the dissolved sugar and water would be a homogeneous mixture. So one thing I like to use as a criteria is whether something looks clear or transparent versus looking cloudy. However, an important exception to this is a metal alloy. So you can mix metals together really uniformly. Some examples of metal alloys would be steel or bronze. And these are mixed uniformly, but they're not transparent because they're metal. So to make steel or bronze, you take different metals, melt them, mix them completely uniformly, and then re-solidify, refreeze them. So these are not elements. Bronze, even though gold is an element and silver is an element, bronze is not an element. It's a mixture of copper and tin. And since it can have that varied ratio, it's also not a compound. So these are mixtures of metals, metal alloys, and they are homogeneous mixtures. So go ahead and pause this if you want to take a look at these. And then when we unpause, I'll go through these problems fairly quickly, just to make sure that we are all on the same page with these terms. Okay, so hopefully we are familiar with the states of matter, at least the three main ones, solid, liquid, and gas. Those are the ones we're going to be working with, none of the more rare states that you could have. So if you put something into a larger container, a solid is not going to expand and fill the container, and neither is a liquid. They have a fixed volume. A gas will expand, so it does not have a fixed volume. As long as we're talking about states of matter, I just wanted to go over the vocabulary for changing state of matter. Going from solid to liquid can be called melting or fusion. Going from liquid to solid is called freezing. Going from liquid to gas is boiling or vaporization. Going from gas to liquid is condensation. And then sometimes we can go straight from solid to gas, that's sublimation. And going from gas directly back to solid would be deposition. So measurements that would change if you brought a block of aluminum to the moon. The weight would change because the force of gravity on the moon has changed, but the mass is the same, and the density, which is the mass over the volume, is also the same because the mass doesn't change and neither does the volume. Water is a compound because we can write a chemical formula for that. Orange juice is a mixture, and it's a heterogeneous mixture because it is not clear, it's cloudy. If you put it under a microscope, you'd see little cell pieces and pulp. Silver is an element. Glucose is a compound. A lot of people know the chemical formula for glucose. Helium is an element. Caffeine is a compound. Even if you don't know the formula, you can look up the formula for caffeine. It is a single substance. You can look up the structure of the molecule. Chocolate milk is a mixture, and again, it's cloudy, so that's heterogeneous. The air in this room, I guess it depends because we are in different rooms. It would be a mixture. There are different compounds and elements in the air in the room. If your air in your room is clear and not cloudy, you can go ahead and call it homogeneous. If you do have a smoky or foggy environment, you can call it heterogeneous. And then metal alloys we mentioned are mixtures, homogeneous mixtures of metals that can vary in composition.